is our the algorithm. The algorithm contains only 3 steps. Step 1, step 2, step 3. Fine? And the main thing about the algorithm is the second part. So how we are going to implement or use this algorithm while solving the transportation problem in this session we are going to see. Fine? So we start with the example number 1. Fine? Example number 1. So in this example number 1, obtain initial basic feasible solution to the TP. Fine? That is origin slash destination. Fine? So it is destination D1, D2 followed by D3, then it is supply. Followed by origin 1, origin 2, origin 3, then demand. Fine. So the value that is 2, 7, 4, 3, 3, 1, 5, 4, 7. That is 7, 9, 18. And by 5, 8, 7. Fine. So one more is there. I am sorry, I have forgotten here. That is 04, that is 162 followed by demand that is 7, 9, 18 followed by this is 14. Fine. So how much it is? 5 into 8, 13. Plus 7, 20 plus 14, that is 34 here. Is 34. So this is what the problem is. Fine. So this is the transportation problem, and we need to find the initial basic feasible solution for this transportation problem using northwest corner rule. The reason why I have not rubbed this algorithm is that I want to implement every step into this problem so that the algorithm again will get more clear to you. Fine? So that's why I have kept this one. So continuing with this solution here. Solution. Since summation AI is equal to summation Bj, that is this one, that is equal to 34. So therefore TP is balanced and there exists initial basic fine. So if you have studied mathematical formulation of transportation problem, and in that what happens, summation AI should be equal to summation Bj, then only the initial basic feasible solution exists. If summation AI is equal to summation Bj, then only we have to use the northwest coordinate. or it can be solved by any of the transportation method problems. Otherwise, you cannot get an initial basic feasible solution. So using the step 1, what step 1 says? Starting with the cell at the upper left corner. What is the upper left corner here? So this is the first cell. This is the first cell. So let me draw the first allocation. The first allocation is made in the cell 1, 1. Therefore, the magnitude is what? That is x11 is equal to minimum of that is for you, that is A1, and this is 7, that is B1, that is A1 comma B1 is equal to 5 comma 7, that is equal to 5. How much is 5? So this is where we are supposed to make the first allocation. Fine. The second allocation is made in the cell. Which cell we are going to do? Made in the cell, that is 21. Therefore, the magnitude is what? x21 is equal to minimum of 8 comma 7 minus 5, that is 8 comma 2, that is 2. So this is how it is done. So how it is done with compared to the algorithm here. So always you have to start with the first cell, that is 1 comma 1, that is the what? Upper left corner, this corner, upper left corner. So we need to check as per the step number 2 if B1 is greater than A1. So which is greater than? This is B1 and this is A1. Which is greater than? We need to find the minimum. That is 5 is the minimum here. So the first allocation is made in cell 1, 1. The minimum of A1 comma B1 is what? A1 is the minimum, that is 5. So the first allocation is done here. So this complete row will get exhausted. Here, either the capacity of the first row is exhausted or the capacity of the first column exhausted. That is, which is the minimum row, that complete row will get exhausted. Fine. So once this complete row is get exhausted, go for the next allocation. Next allocation is made in cell 2, 1. So this is get subtracted, that is 7 minus 5. So next allocation is made here. So which is greater than? Either 8 is greater or either 2 is greater. That is 8 comma 2. So this is smaller one. So this complete column is get exhausted. And further when I solve this one, we will come to know here. But I just wanted to give you the exact replica of how the problem is solved compared to the what? Algorithm. So check my time. So when supposed to continue with the finding initial basic feasible solution, so I have to redraw this table here and solve it. Fine. So that will be done in the next class. Thank you.